On December 19, 2025, how close will 3i Atlas come to Earth, really? Not in headlines, not in dramatic language, but in direct comparison with the only two interstellar objects we've seen before, Oumuamua and 2i Borisov. All three passed through our cosmic neighborhood. But they did not pass at the same distance. They were not discovered at the same time, and they were not observed in the same way. In this video, we won't re-explain what these objects are. Instead, we'll place all three on the same scale, using the same measurements and the same definition of near. By the end, you'll have a clear answer to one question: why this pass in 2025 is being watched more closely than any interstellar visit before, even if it isn't the closest. Let's start by defining what near-Earth actually means in astronomy. When we ask how close an object comes to Earth, the question sounds simple. But in astronomy, the word close does not mean what it means in everyday life. In daily experience, close is something we can walk to: a nearby store, a house across the street, a city a few miles away. In space, close operates on a completely different scale. An object can be described as near Earth even when it is tens of millions of kilometers away. That distance is far beyond anything we experience directly, yet in astronomical terms, it is considered part of Earth's neighborhood. This difference often creates confusion. When people hear that something is near Earth, they imagine proximity in human terms. They imagine visibility. They imagine immediacy. But astronomy is not built around human intuition. It is built around motion, gravity, and geometry. Space rarely gives us simple answers. In technical language, near Earth does not mean close enough to touch or even close enough to see without instruments. It means close enough that Earth's gravity, orbital position, or observation systems become relevant. It is a category defined by scale, not sensation. This is why two objects can both be described as near Earth and yet feel completely different to us. One may pass unnoticed until long after it has gone. Another may be tracked for months, not because it is closer, but because we know where to look. Numbers whisper more than they speak. Distance alone does not determine how an encounter feels. Timing matters, speed matters, the angle of approach matters, and perhaps most importantly, our level of awareness matters. An object passing farther away can feel more present than one that came closer, simply because we are paying attention this time. Our instruments are better. Our expectations are sharper. Our memory of previous encounters shapes how we interpret the next one. Silence is also a kind of data. When astronomers describe something as near Earth, they are not describing a threat or an event. They are describing a position in space relative to a moving planet at a specific moment in time. And this is where language begins to blur perception. The same word is used, but the experience behind it changes. As we compare different interstellar visitors, the distances will matter. But how we perceive those distances may matter even more. In space, closeness is not a feeling, it is a measurement. And measurements, when viewed calmly, often reveal how small our assumptions really are. When three interstellar visitors pass through our region of space, it is tempting to tell their stories one by one. But stories can distract from something more precise. Instead, imagine placing all three on the same scale, not as narratives, but as positions. Not as mysteries, but as distances. Oumuamua arrived first. It passed through quietly and left just as quietly. Its closest approach to Earth was distant enough that it barely entered public awareness at the time. By the time it was identified, it was already moving away, its trajectory more a reconstruction than an observation. It was near in astronomical terms, but remote in experience. Numbers whisper more than they speak. Then came 2i Borisov. It followed a path that was easier to track and slower to interpret. Its distance from Earth at closest approach was still large, but its behavior fit expectations more closely. It did not challenge definitions. It did not force reinterpretation. It passed at a measurable distance, observed with steady confidence, and then continued on its way. Silence is also a kind of data. Now place 3i Atlas on the same axis. Not as an object to explain, but as a point in space relative to Earth's orbit. Its closest approach does not represent a dramatic shift in physical risk, but it does represent a shift in context. This time, the distance is measured earlier. The tracking begins sooner. The observation window is wider. What feels different is not only where it passes, but when we start paying attention. Space rarely gives us simple answers. All three objects can be described as near Earth, yet their nearness does not feel the same. One was noticed too late, one behaved as expected, and one is being watched in real time, long before its closest approach. Placed on the same scale, the difference becomes clear. The distances themselves do not change dramatically. What changes is our relationship to those distances. We are no longer reacting, we are preparing, we are measuring without urgency. And in that quiet preparation, perception shifts. This is why this passage feels different from the two before it. Not because space has changed, but because our way of observing it has. Closeness in space is not only a matter of kilometers, it is also a matter of readiness. And sometimes, what truly approaches is not an object, but a clearer understanding of where we stand. When Oumuamua passed through the inner solar system, it did not come close to Earth in the way that word is often imagined. Its trajectory kept it far beyond the distances of everyday cosmic neighbors. It did not skim past our planet. It did not enter Earth's immediate gravitational influence. In physical terms, the encounter was distant and uneventful, yet it was still described as near Earth. In astronomy, that description reflects scale, not sensation. Oumuamua passed within a region of space that is considered close only because the solar system itself is vast. Measured in kilometers, the separation was immense. Measured against interstellar distances, it was relatively small. Numbers whisper more than they speak. What defined this encounter was not how close Oumuamua came, but when it was noticed. By the time telescopes identified it as unusual, it was already moving away from both the Sun and Earth. Its closest approach had already passed. The geometry of its path had to be reconstructed after the fact, using faint signals and limited observation time. Silence is also a kind of data. From a scientific perspective, this timing mattered more than distance. The object was never unobservable, but it was not observed when it mattered most. There was no long lead time, no extended tracking window, no opportunity to prepare instruments in advance. In that sense, humanity was not watching an approach, it was tracing a departure. Space rarely gives us simple answers. This created a unique context. Oumuamua was near in position, but far in awareness. Its presence was defined less by where it was in space, and more by where our attention was not. This distinction is easy to overlook. Closeness does not guarantee visibility. Distance does not determine understanding. Observation depends on timing, alignment, and readiness. When scientists later spoke about how near Oumuamua had been, the phrase carried an abstract meaning. It referred to orbital math and relative motion, not to any moment of shared proximity. Placed alongside later interstellar visitors, the contrast becomes clear. Oumuamua represents a case where an object passed through a measurable neighborhood of Earth, yet remained functionally distant in human experience. It reminds us that in astronomy, being near does not mean being seen. It means passing through a coordinate system we only partially monitor. And sometimes, The most instructive encounters are the ones we notice only after they are already gone. When 2I Borisov passed through the inner solar system, its path brought it closer to Earth than Oumuamua had been. In purely spatial terms, the separation was smaller. The geometry of the encounter placed it more clearly within a region that astronomers monitor with confidence. Yet the response to this passage was notably quieter. Numbers whisper more than they speak. The reason was not distance, it was behavior. From the beginning of its observation, 2I Borisov behaved in ways that were familiar. Its motion followed predictable patterns. Its interaction with sunlight produced effects long associated with comets formed within our own solar system. Nothing about its activity challenged established models in a visible way. Silence is also a kind of data. Because of this, the encounter felt stable. Even as measurements showed that it was closer than the earlier interstellar visitor, it did not feel closer in any emotional or perceptual sense. There was no urgency in how it was tracked. No need to reinterpret existing frameworks. The instruments were pointed, the data was collected, and the object continued along its trajectory. Space rarely gives us simple answers. In this case, the simplicity was the point. 2I. Borisov confirmed rather than disrupted. It demonstrated that an interstellar object could pass near Earth and still behave like something we already understood. This highlights an important distinction. Closeness in space does not automatically translate to attention. What draws focus is not only where an object passes, but how it acts while doing so. An object that fits expectation can pass quietly, even when it comes nearer. An object that defies expectation can feel present, even at greater distances. Numbers whisper more than they speak. When scientists later compared the two encounters, the contrast was clear. Oumuamua was distant but unsettling in its ambiguity. 2I. Borisov was closer, yet calm in its consistency. The physical distance mattered less than the cognitive distance. One expanded uncertainty, the other reduced it. This is why the passage of 2I Borisov did not generate a lasting sense of unease. It did not suggest new categories. It did not force revisions to fundamental assumptions. Instead, it reminded observers that not every close encounter demands emotional weight. Some are simply part of a larger, steady pattern. And in the quiet movement of 2I Borisov, there was a subtle lesson. Not everything that approaches us in space asks for concern. Some things pass close, behave as expected, and leave behind understanding rather than questions. To understand how close 3I Atlas will come to Earth, it helps to stop thinking in isolated events and start thinking in alignment. Not three separate stories, but one shared axis of distance. When placed on that axis, the passage on December 19, 2025 becomes easier to interpret. 3I Atlas will not skim past Earth. It will not enter the realm of satellites, the moon, or even the inner layers of near-Earth space as we usually imagine them. Its path remains comfortably distant in physical terms. Yet compared to earlier interstellar visitors, its position occupies a meaningful place on the scale. Numbers whisper more than they speak. Relative to Oumuamua, 3I Atlas will pass closer to Earth. Oumuamua's encounter was distant and already receding by the time it drew attention. Its closest point was reconstructed after the fact, leaving little opportunity to observe the approach itself. In contrast, 3I Atlas is being tracked well in advance. Its motion is known ahead of time. Its path through space is not a surprise unfolding after it has passed. This alone changes how the distance feels. Silence is also a kind of data. When compared to 2I Borisov, the picture shifts again. Borisov passed at a distance that was closer than Oumuamua, but its behavior placed it comfortably within familiar patterns. 3i Atlas does not necessarily come closer than Borisov in a dramatic way. What distinguishes it is not an extreme change in separation, but the clarity of the comparison itself. Placed between these two encounters, 3i Atlas occupies a middle ground, closer than the first, comparable in scale to the second, but observed under very different conditions. Space rarely gives us simple answers. Instead of focusing on exact figures, imagine three paths crossing a wide field. One passes far at the edge, noticed only as it leaves. One passes nearer, steady and predictable. And one passes through a region we now monitor more carefully than ever before. The distances between these paths are real, but subtle. What grows larger is our ability to see them clearly. This is why the December 2025 passage stands out. Not because it breaks records, but because it completes a sequence. It allows all three interstellar visitors to be compared on the same frame with the same awareness. In the end, 3i Atlas is neither the closest nor the farthest. It is simply the one that arrives when we are ready to measure calmly. And sometimes, clarity itself is the closest encounter we ever get. From a purely physical standpoint, this passage is no different from the two before it. There is no collision path, no intersection with Earth's orbit, no expectation of impact. And yet, the feeling surrounding this encounter is not the same. The difference does not come from space itself, it comes from memory. After the first two interstellar visitors, something subtle changed in how we observe. Oumuamua taught us what it feels like to notice too late. 2i, Borisov showed us how familiar behavior can quiet uncertainty. Together they formed a kind of observational memory, not emotional but methodological. Numbers whisper more than they speak. This time, detection came earlier. Not because the object was dramatically closer, but because our systems were already watching more carefully. Surveys scan wider areas. Algorithms flag unusual motion sooner. What once required reconstruction now unfolds in real time. Silence is also a kind of data. Early detection changes everything. It stretches time. Instead of a brief glimpse, there is a long approach. Instead of a hurried analysis, there is patient tracking. The object remains distant, but our attention stays with it. Longer observation means more data. More data means fewer unknowns, and fewer unknowns shift the nature of the questions being asked. Space rarely gives us simple answers. The curiosity now is quieter, but deeper. The question is no longer, "What is this?" or "Where did it come from?" Those questions still exist, but they are framed differently. They sit inside more refined models and longer timelines. Familiarity does not reduce interest, it changes its texture. When something happens once, it surprises us. When it happens again, it reassures us. When it happens a third time, it invites comparison. That is where we are now. We are no longer reacting to an unexpected event. We are observing a pattern emerge. The absence of danger is understood. What remains is attention. Numbers whisper more than they speak. The sense that this encounter feels different is not a contradiction. It is a consequence of learning. The object is still distant. The path is still safe. But the context has matured, and in that maturity, curiosity becomes more precise. Less about fear, more about understanding. Sometimes, the most significant change is not in what approaches us, but in how quietly we are prepared to watch it pass. When we talk about how close an object comes to Earth, we often imagine distance as a single number. But in astronomy, closeness has another dimension that matters just as much: time. Oumuamua moved through the inner solar system quickly. Its velocity was high, and its window of visibility was short. By the time its unusual nature became clear, the object was already leaving. There was little opportunity to follow it step by step. The encounter felt brief, almost fleeting. Silence is also a kind of data. Then came 2I Borisov. Its motion was slower, and its behavior was easier to anticipate. The observation period was longer, but the experience remained steady. There was time to measure, time to confirm, and time to watch it fade. Yet the encounter did not linger in attention because it did not demand reinterpretation. Numbers whisper more than they speak. Now consider 3I Atlas. Its path does not bring it dramatically closer in space than the others. What sets it apart is how long it stays within our field of awareness. Detection comes earlier. Tracking lasts longer. The object remains distant but present. This extended presence changes the nature of observation. Instead of a quick response, there is continuity. Instead of a moment, there is a season. Astronomers do not rush to define what they see. They return night after night, watching how the object behaves as conditions change. Space rarely gives us simple answers. Time creates room for reflection. With a longer observation window, questions become more careful. Patterns emerge gradually. Small deviations become noticeable. The focus shifts from reaction to understanding. An object that passes quickly may be closer in space, but farther in experience. An object that remains in view invites thought, even if it never comes nearer. This is why time matters when we talk about closeness. It shapes how an encounter feels. It determines whether we glance or observe. It defines whether we remember a moment or study a process. In the case of 3I Atlas, the extended time in view allows something rare. It allows patience. And patience changes curiosity. When an object stays within our attention long enough, it gives us space to think, not urgently, not emotionally, but steadily. In astronomy, closeness is not only measured in kilometers, it is measured in nights of observation. And sometimes, being near for longer is what allows understanding to quietly take form. Imagine for a moment that Earth is not the reference point. Imagine that the observer is standing somewhere else. When 3I Atlas passed closer to Mars, the event itself did not change. The object followed its path with the same speed, the same trajectory, the same indifference to where planets happened to be. What changed was perspective. From Earth, the passage near Mars triggered a shift in attention. People began to imagine scenarios. They wondered what it meant for a planet already studied for its past chemistry and thin atmosphere. They asked questions not because the situation demanded them, but because the viewpoint had moved. Numbers whisper more than they speak. From the object's frame of reference, nothing special occurred. There was no encounter, no decision point, no response. The trajectory remained governed by gravity and momentum, untouched by interpretation. Space rarely gives us simple answers. The contrast reveals something important. Concern does not arise from motion, it arises from location. When the object passed near Mars, it was not suddenly more significant. It simply entered a region of space where human attention already lingered. Silence is also a kind of data. Mars carries meaning for us. Earth carries even more. When an object moves near these places, we do not observe it in isolation. We observe it through layers of expectation, memory, and projection. If Earth and Mars were exchanged, the physical event would remain identical. The orbit would not bend differently. The speed would not change. Only the story we tell ourselves would shift. This is where perception becomes part of the equation. The object is neutral. Its path is neutral. What fluctuates is the human response. The sense of unease does not live in the object itself. It lives in the frame from which we observe it. Time plays a role here as well. When an object remains near a point of interest for longer, it creates space for speculation. Not urgency, but thought. The longer the attention window, the more the mind fills the silence. Numbers whisper more than they speak. This is why prolonged observation can feel heavier, even when nothing changes physically. We are not reacting to danger, we are responding to presence. In astronomy, distance and time are measurable. Concern is not. By shifting the viewpoint, we see that what feels significant is often a reflection of where we stand, not what passes by. And sometimes, the quiet lesson is this. Space moves without intention. Meaning appears only when we decide where to look. When an interstellar object enters the public conversation, media coverage often focuses on one word more than any other: near. The reason is simple. Near is immediate. It compresses vast scales into something that feels personal. It suggests relevance without requiring explanation. Distance, by contrast, asks for patience. It requires context. It invites comparison, not reaction. Numbers whisper more than they speak. In astronomy, distance is precise. It can be calculated, modeled, and verified. But precision does not always translate into understanding. Large numbers lose meaning when they are removed from familiar reference points. When a report says an object is near Earth, many listeners do not ask near compared to what. They ask, what does that mean for me? The word near does the emotional work before the data is even considered. Space rarely gives us simple answers. This is why proximity becomes the headline. Not because it is misleading, but because it is incomplete. It frames the event in terms of feeling rather than structure. Distance measured in millions of kilometers can sound alarming or trivial depending on how it is presented. Without context, the same number can suggest intimacy or irrelevance. Media language often chooses the interpretation that holds attention the longest. Silence is also a kind of data. Another reason nearness dominates coverage is that motion is abstract. Orbits, trajectories, and relative velocity do not translate easily into everyday experience. They require diagrams. They require time. Near requires only a word. This does not make the coverage wrong, it makes it selective. Human attention responds more readily to sensation than to scale. We are wired to notice what feels close, not what is mathematically defined. As a result, the nature of an object often receives less focus than its position relative to us. Numbers whisper more than they speak. The challenge is not misinformation, but simplification. Complex systems are reduced to accessible language, and something is always lost in that process. For science communicators, this creates a tension. How to remain accurate while still being heard. How to speak in numbers when the audience listens in feelings. In the end, the emphasis on nearness reveals more about us than about the object itself. It reflects how we translate the universe into terms we can absorb. And perhaps the quiet reminder here is this. Understanding space begins not with how close something is, but with how carefully we choose the words we use to describe it. It is reasonable to ask a simple hypothetical question. If 3i Atlas were a little farther away, would anything truly change? If its path placed it beyond the distance of 2i Borisov, would the attention soften? If it passed at a range similar to Oumuamua, would the conversation feel quieter? At first glance, distance seems like the deciding factor. Closer feels important. Farther feels remote. But space rarely gives us simple answers. From a physical standpoint, a modest change in distance would alter very little. The object would still follow a predictable trajectory. Its motion would remain governed by gravity and momentum. No new physical interaction would suddenly appear or disappear. Numbers whisper more than they speak. What would change is not the event itself, but the frame in which it is received. Distance alone does not define significance, context does. If 3i Atlas had passed farther than Borisov, it would still arrive in a time when we are prepared to notice it. Early detection systems would still track it. Data collection would still begin well before its closest approach. The observation would remain deliberate and extended. If its distance matched that of Oumuamua, the difference would still be clear. We would not be discovering it after it had already left. We would not be reconstructing its path in hindsight. The awareness would come first, not last. Silence is also a kind of data. This reveals a quiet truth. The meaning of an encounter is shaped less by kilometers than by history. What we have already experienced informs how we interpret what comes next. Oumuamua arrived before we were ready. Borisov arrived when we were learning how to observe calmly. 3I. Atlas arrives after those lessons have settled. Space rarely gives us simple answers. In this sequence, the object does not need to be closer to feel more present. It needs only to arrive later, into a more informed moment. Distance can shift perception at the margins, but it does not rewrite the story. The story is written by preparation, memory, and comparison. Numbers whisper more than they speak. When we imagine alternate distances, we often assume different outcomes. But in this case, the outcome remains largely the same. The path is safe, the motion is neutral, the observation is intentional. What has changed is us, and perhaps that is the quiet conclusion of this thought experiment. The universe does not need to move closer to feel more meaningful. Sometimes meaning grows simply because we are standing at a different point in time, ready to notice it. Across 3 interstellar passages, space has remained the same. What has changed is us. The first encounter arrived without preparation. There was no established reference, no shared expectation. The data appeared incomplete, the interpretations uncertain. The dominant response was not alarm, but confusion. Observers worked backward, reconstructing motion from fragments. The experience was marked by questions that arrived faster than answers. Silence is also a kind of data. By the time the second visitor appeared, something had shifted. The unknown had become familiar enough to place within a framework. Instruments were ready. Language was steadier. The object behaved in ways that fit existing models, and the response followed suit. This was not indifference, it was composure. Numbers whisper more than they speak. The second encounter did not demand reinterpretation. It confirmed that interstellar objects could pass through our region of space without disrupting established understanding. The event unfolded with clarity, and then concluded quietly. Now comes the third passage. This time, there is neither confusion nor simple acceptance. Instead, there is reflection. Space rarely gives us simple answers. With memory comes comparison. With comparison comes perspective. The focus is no longer on identifying what something is, but on understanding how it fits into a growing pattern. The third encounter invites synthesis. It is observed early, tracked steadily, and discussed with restraint. The absence of urgency is intentional. The questions being asked are fewer but more precise. There is no fear here, not because risk has vanished, but because knowledge has matured. The unknown has been reduced to scale rather than sensation. Numbers whisper more than they speak. This progression reveals something subtle about human perception. We do not respond only to events. We respond to sequences. The first encounter unsettled. The second stabilized. The third encourages thought. Each passage reshapes our internal landscape more than it reshapes space itself. What began as confusion becomes familiarity. What became familiar turns into understanding. And understanding opens space for contemplation. Silence is also a kind of data. In this sequence, interstellar visitors are not threats or messages. They are markers in our own development as observers. They show us not how space changes, but how our way of seeing evolves over time. And perhaps that is the quiet meaning of these 3 visits. The universe does not need to speak loudly to teach us. Sometimes it only needs to pass by, again and again, while we learn how to listen more carefully. When scientists describe an encounter as safe, the statement is precise. It is based on trajectories, velocities, and gravitational models. These calculations define where an object will be, when it will be there, and how it will move relative to Earth. From this perspective, uncertainty is limited. Paths are traced forward and backward in time. Margins of error are measured and refined. Within those boundaries, conclusions are calm and consistent. Numbers whisper more than they speak. Yet, human reaction follows a different logic. When people hear that something will pass near Earth, the mind often drifts toward possibility rather than probability. The question that surfaces is rarely what the orbit shows, it is what could happen. This difference is not a failure of understanding, it is a feature of human perception. Space rarely gives us simple answers. Science asks whether an object will intersect a path. Imagination asks what that intersection might mean. Science closes the case when the geometry is resolved. Imagination keeps the case open, even after the math is settled. Silence is also a kind of data. This gap explains why reassurance does not always quiet curiosity. Physical distance can be large, yet emotional distance remains small. An object can be safely removed from any collision scenario while still feeling present in thought. The mind does not scale emotion the way it scales numbers. Millions of kilometers can still feel close if attention is sustained. A long observation window can amplify awareness even when risk does not increase. Numbers whisper more than they speak. In this way, distance in space does not correspond neatly to distance in feeling. The two operate on different systems. One is governed by physics, the other by narrative and anticipation. This does not diminish the value of scientific certainty, it highlights the role of context. Safety, in scientific terms, answers a specific question. It does not address the broader human tendency to imagine alternatives. Space rarely gives us simple answers. Understanding this difference allows both perspectives to coexist. The calculations remain valid. The curiosity remains natural. In the end, the quiet tension between certainty and speculation is not a contradiction. It is part of how humans engage with the unknown, and perhaps the calm realization is this. Even when science draws a clear boundary, the human mind continues to explore the space just beyond it, not in fear, but in search of meaning. When looking back across interstellar encounters, it becomes clear that closeness alone has never been the defining factor. Distance can vary, speed can change, trajectories can differ. But what truly shapes understanding is visibility. 3i Atlas is not the closest interstellar object to pass through our region of space. It is not the fastest. It is not the most physically threatening. From a purely mechanical perspective, it does not occupy an extreme position on any scale, and yet it stands apart. Numbers whisper more than they speak. This passage is defined by how clearly it can be observed. Detection came early. Tracking began well before the closest approach. The motion is followed steadily rather than reconstructed afterward. This clarity changes the entire experience. Space rarely gives us simple answers. In earlier encounters, scientists worked with fragments. Observations arrived late or ended quickly. Questions outpaced data. Uncertainty filled the gaps. With 3i Atlas, the situation is reversed. The data arrives first, the questions follow. Silence is also a kind of data. Long observation windows allow patterns to emerge gradually. Subtle changes become noticeable. Measurements can be repeated and refined rather than rushed. This does not make the object more important in physical terms, it makes it more informative. The absence of danger is well understood. The lack of urgency is intentional. What remains is attention, sustained and careful. Numbers whisper more than they speak. This distinction matters. An encounter does not need to be extreme to be meaningful. It needs to be seen clearly. In this case, clarity does not come from proximity. It comes from preparedness. By the time 3i Atlas arrives, the tools are ready. The expectations are grounded. The context is established. This allows observation without pressure, understanding without haste. Space rarely gives us simple answers. When viewed this way, the significance of this passage becomes quiet and precise. It is not a moment of risk. It is a moment of resolution. The clearest encounter is not always the closest one. Sometimes, it is the one that arrives when we are finally ready to see it for what it is. And perhaps that is the lasting insight here. In the vast movement of space, meaning does not emerge from nearness but from clarity, patience, and the willingness to observe without expectation. When we hear that an object passes near Earth, it can feel unusual, as if something rare has interrupted a quiet system. In reality, this kind of passage is not exceptional at all. Throughout the history of the universe, objects have always been moving. Stars orbit within galaxies. Planets drift through evolving systems. Smaller bodies pass between them, guided only by gravity and momentum. What changes is not the motion itself. It is our ability to notice it. Numbers whisper more than they speak. Long before humans existed, objects passed through this region of space. They came and went without record, without observation, without meaning assigned to them. Earth was still there. The solar system continued its path. Nothing paused. Space rarely gives us simple answers. When we describe a 3i Atlas as near Earth, we are placing a familiar label on a very ordinary cosmic behavior. The object is not doing something new. It is doing something ancient. What is new is our perspective. Silence is also a kind of data. Only recently have our instruments become sensitive enough to detect these travelers early. Wide-field surveys now scan the sky continuously. Patterns of motion that once blended into the background are now recognized and flagged. This gives the impression that something has changed in space, but it has not. The universe has always been active. It has always been filled with motion. We are simply beginning to see more of it. Numbers whisper more than they speak. From this broader view, nearness loses its urgency. Passing objects are part of a steady flow rather than isolated events. They do not arrive with intent. They do not respond to our attention. They pass because motion continues. This perspective shifts the meaning of observation. Instead of asking why something is happening now, we ask why we are noticing it now. The answer lies not in the sky, but in ourselves. Space rarely gives us simple answers. The tools we build shape the universe we perceive. As our vision improves, the universe appears more populated, more dynamic, more complex. But it was always this way. What we are witnessing with 3i Atlas is not an exception to cosmic behavior. It is a correction in human awareness. The universe has not moved closer. It has remained exactly where it has always been. The change is quieter than that. We are learning to look. And in that slow adjustment, a simple truth emerges. The cosmos does not suddenly reveal itself. It waits patiently while we gradually open our eyes wide enough to see what was always there. So how close does 3i Atlas actually come to Earth? The answer sits quietly between two extremes. It is far beyond anything we encounter in daily life. Far beyond the moon. Far beyond the satellites that circle our planet. Even far beyond the distances that usually feel familiar when we think about space nearby. In human terms, it is not close at all. And yet, within the scale of the universe, the picture changes. Numbers whisper more than they speak. Compared to the vast separations between stars, galaxies, and interstellar space, this passage occurs remarkably nearby. Most objects that travel between star systems never come anywhere near the region we can observe in detail. They pass unseen, their paths lost in distance and time. 3i Atlas does not. It enters a zone where our instruments can follow it steadily, where its motion can be traced without urgency, where observation is possible not just in passing, but over time. Space rarely gives us simple answers. This is what makes the encounter feel balanced. It is distant enough that there is no physical concern. Its trajectory is well understood. Its passage poses no disruption. At the same time, it is close enough to invite reflection, to allow comparison, to encourage careful attention rather than reaction. Silence is also a kind of data. This middle ground is easy to overlook. We tend to think in absolutes, too close or too far, safe or dangerous, important or irrelevant. But many meaningful moments sit in between. 3i Atlas occupies that space. It is not an event that demands urgency. It is an opportunity that allows thought. Numbers whisper more than they speak. The distance is sufficient to remind us how large space truly is, and yet small enough to remind us that we are not isolated from it. This balance shapes how the passage is experienced, not as a warning, not as a spectacle, but as a quiet alignment between motion and awareness. In the end, the question of closeness resolves into something simple. 3i Atlas is far enough away to leave us undisturbed, and close enough to leave us curious. That may be the most meaningful distance of all. It gives us room to think without fear, room to observe without urgency, and room to remember that in a vast universe, understanding often begins not with proximity, but with perspective. After comparing distances, timelines, and observations, a quiet realization begins to take shape. The difference does not lie in 3i Atlas. It does not lie in Oumuamua. It does not lie in Borisov. Each of these objects followed its path with the same indifference. They moved according to gravity, momentum, and time. None adjusted its course in response to being seen. None carried awareness of our attention. Numbers whisper more than they speak. What changed between these encounters was not space. It was perspective. The first time, we were unprepared. Our tools were limited. Our expectations were narrow. We noticed motion only after it had passed. The second time, we were steadier. We recognized patterns. We measured calmly. The encounter fit within what we already understood. Now, in the third instance, something subtler is happening. Space rarely gives us simple answers. We are not rushing to explain. We are not surprised by the concept of interstellar visitors. We are no longer asking whether such passages are possible. Instead, we are asking quieter questions. How often does this happen? What can repeated observation reveal? How does awareness evolve over time? Silence is also a kind of data. These questions do not arise because the object is closer. They arise because we are standing at a different point in history. Our instruments have improved. Our memory has lengthened. Our confidence has stabilized. With these changes, the same type of event produces a different internal response. Less urgency, more reflection. Numbers whisper more than they speak. This shift does not reduce wonder. It refines it. We are no longer startled by the presence of something unfamiliar. We are attentive to what familiarity allows us to see. The universe continues as it always has. Objects pass. Distances remain vast. Paths remain neutral. What evolves is our relationship to these movements. Space rarely gives us simple answers. In this moment, the significance of the passage is not in how near it comes. It is in how prepared we are to observe it without distortion. The difference is not in the visitor, it is in the observer. And perhaps this is the quiet truth that lingers after all comparisons are complete. When the universe remains unchanged and our understanding deepens, the most meaningful journey is not the one crossing space, but the one unfolding slowly within us, as we learn how to see more clearly. As the night settles, it helps to step back and see the larger pattern. 3 visitors passed through. Each followed a different path. Each crossed a different distance. And through it all, Earth continued to turn. The planet did not pause. Its rotation remained steady. Days followed nights. Seasons continued their quiet cycle. Numbers whisper more than they speak. The universe did not announce these passages. It did not signal importance or intent. The motions unfolded in silence, guided by gravity alone. Space rarely gives us simple answers. What changed was not the sky, it was attention. The first passage caught us off guard. The second reassured us. The third invited reflection. Together they form something gentle rather than dramatic. A reminder that motion is constant even when unnoticed. That proximity does not demand alarm. That understanding grows through repetition and patience. Silence is also a kind of data. In the vastness of space, distance is measured without emotion. Objects move, paths cross. Then they separate again. Meaning enters only when we choose to observe. Tonight there is no urgency in this story. No unresolved question that needs an answer before sleep. Only a quiet recognition that the universe continues its rhythms, indifferent to whether we are watching. Numbers whisper more than they speak, and yet, listening has changed. With each encounter, we have learned to notice more carefully, to respond with steadiness rather than surprise, to let curiosity replace concern. Earth remains where it has always been. The universe remains vast. The difference is subtle but real. Space rarely gives us simple answers. As you rest, imagine those paths stretching outward far beyond sight, not as threats, not as messages, but as reminders of motion without intention. 3 visitors, 3 distances, 1 world continuing its quiet spin. The universe remains silent, but silence does not mean absence. It means space. Space for thought, space for perspective, space for calm. And perhaps that is enough for tonight. As the earth turns and the sky holds its stillness, we are learning, slowly and gently, how to listen without needing the universe to speak.